Science. Serial 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 science.
Good morning, and welcome back to Serial Science. Every week we host an Ask Me Anything with a super awesome science guest. And this week I am really excited to talk to Nathalie Ouellette. Nathalie's from Montreal. She works at the Institute for Research on Exoplanets. So that's right, that is the search for habitable worlds and alien life. So beam up all your space questions. She is also worked on the James Webb Telescope. So that is basically going to be the next Hubble, our biggest and best set of eyes on the sky. And she's also an outreach scientist, which means she spends a lot of time talking to people, answering their questions. So you can definitely fire up all of your space questions for Nathalie. We're going to talk a little bit about space radiation. So what is it? Is it dangerous? Could it give you superpowers? Could you get bit by a radioactive spider? So fire up your gamma ray questions. So welcome, Nathalie. Good morning.
Hi, good morning.
So why don't you kick us off with an easy one? What is space radiation?
So space radiation sounds really exotic. It sounds like something dangerous or something really extreme, but really everything radiates. So maybe you've heard of something called the electromagnetic spectrum, and I can show you really quickly what that looks like in a little picture. And this is basically all kinds of light, all the different kinds of light.
And everything you can see.
Everything you can see. So what the kind of light or radiation we know best is visible light. It's what we can use to look around us. And the sun shines really brightly in that. But there's all kinds of radiation beyond that. And when we think of radiation, we think of the types of light that are a lot more energetic than visible. So gamma rays, X-rays, ultraviolet rays. But there are some types of light that are like even less energetic than visible, like radio waves, microwaves, infrared. But
And that's all space radiation.
all of that is radiation, and space radiation just means that it's coming from something in space.
Okay. So does everything give off radiation? Like the sun gives off radiation, the light, we see that. Does everything give off radiation? Does the moon? Does the
You are giving off radiation right now.
Okay.
Actually, yeah. So radiation is usually associated with with the temperature of an object. So
For sure.
something that's really, really hot will peak. Its radiation is
sun.
going to peak higher in the energy. So a really, really hot star will peak more in ultraviolet, or a really cold star will peak more in infrared. And then you have some things that are like really intense, supernova explosions or gamma ray bursts. They are super hot, super energetic, and they will peak in more energetic types of radiation.
Oh, okay. So tell me about those like more energetic types of radiation. Like this is kind of the stuff that you see, that you hear about in comic books. This is where people get their powers from. Like what is it? What does it actually do to people or to life?
So in the comic books, you would almost want to go and like play around in radiation and hope you get superpowers. And the reason why we sort of like think that is because radiation can start sort of playing around with your DNA, with your genetic code. So your DNA or genetic code is what makes you you. It's all the building blocks that make you you. And sometimes you can get mutations in that. And like some mutations can be like really benign. Like red hair is something of a mutation, and it is in your genetic code. Red hair is cool. I like people with red hair. It's not a superpower though.
It's pretty close. I think if you are redheaded yourself, you might call it that.
Exactly. But in the comic books, the people who are close to radiation, their cells and their DNA will be mutated to give them things like super strength, or like X-ray vision,
the power to fly. Yeah,
exactly. But what's closer to reality, unfortunately, typically the mutations that you get from radiation are actually harmful to you. They're not going to give you superpowers. They might actually give you something like cancer. So it's not good radiation, and it gives you bad mutations. So
sure.
It is more likely to be harmful than it is to give you superpowers, unfortunately.
So we have a question from the audience. Does that mean Jean Grey is double the mutant? I believe she's also a redhead.
That's a good point. Yes. Not only is she a redhead, but she is like an unreasonably fiery redhead.
Yes.
That shade of red is very, very.
No big deal.
That's right. So I guess she is a double omega level mutant.
Absolutely. And so you said this radiation is most often, the mutations would be dangerous. They would be bad for you. So how do we protect ourselves? We're always in the sun. We're always seeing daylight. We're probably not getting quite as much of the gamma rays and the extreme radiation, but why don't you talk to us a little bit about that?
So what's really handy is we are protected by the Earth's atmosphere and also by the Earth's magnetic field. So we don't have to do very much to be protected from the really, really dangerous stuff, the gamma rays that are coming from space. So I can show you a little diagram here as well. So here on the side, you have the Earth on the left side, and you see all of the blue lines around it. That's the magnetic field of the Earth. And the sun is blasting us with charged particles all the time. But because they're charged, they interact with the magnetic field of our Earth, and our Earth is shielded from all of those things. Sometimes they can...
Superpower.
The Earth has a superpower. It's like shielded from these rays. So for the most part, we're protected. We also have the ozone layer, which protects us from ultraviolet light, most ultraviolet light. Sunscreen will do the rest. But we are protected for the most part from these really, really dangerous things. If you happen to be on the Earth and you're working near a nuclear reactor or something like that, certain types of materials can also block out radiation. So lead is a really good thing. Okay. We can like line buildings or suits with lead so that it prevents the radiation or the radioactive particles from penetrating that clothes and hitting your DNA.
So a closer to home example, is it okay to stand by the microwave?
It is
are we getting those
okay.
rays?
They would not sell you microwaves in your home if they
That's
were
true.
not safe. So microwaves are totally fine. It's built in such a way that it is not dangerous. Just don't put any metal in the microwave.
Yes, that can be actually very dangerous.
Yeah.
So you mentioned that everything gives off radiation, even us. So Spider-Man, his origin story, bit by a radioactive spider. So there could be a radioactive spider. Another reason to be afraid of spiders in my books, but
There could be a radioactive spider, but very likely the spider might die before it gets to you to bite you. Also, radioactivity, we tend to see it as something that's very contagious, almost like a disease. So there was an HBO series on television recently about Chernobyl, which was like one of the biggest nuclear disasters in history. And the way that they portrayed it, and it was criticized, all the workers who worked to put out the fire in Chernobyl, they were almost like treated like radioactive zombies in the movie, where like if you get close to them, you would like catch the radioactivity.
So you can't catch it. You can't get it from someone.
If they are decontaminated, if all the radioactive dust is like brushed and cleaned off of them, they will still feel the effects of the radioactive poisoning, but they can't then give that radioactive poisoning to someone else. Only a radioactive material.
The dust or
Exactly. So that was a little bit overblown in that TV show.
Oh, television. Cool. So so is all radiation dangerous then? There's lots. We've talked about different kinds.
Not only is not all radiation dangerous, but some radiation we use to our own benefit. So
tell me about this.
Radio waves. That's something that it's considered light and radiation, and we use it for telecommunication. So radio waves, what's really handy is that our atmosphere is completely transparent to them. So I mentioned that our atmosphere is like blocking out really dangerous stuff.
It's the shield.
Exactly. It's like a shield that's protecting us. But the shield, it lets radio waves pass through. So we can do things like send radio waves to the other side of the earth or communicate with like a satellite we sent up into space.
So they're all radio waves.
Yeah, it's all radio waves. So we can use radio waves to our benefit. Even the really dangerous ones, like X-rays, we can use to our benefit. We use X-rays in medicine to look inside of our bodies and like, is there a broken bone or something? But you still have to protect yourself, because if you are constantly bombarded with X-rays, that gets to be a little dangerous, which is why you get like the little vest when you go to the dentist. They put that like really heavy vest. It's to protect you from X-rays, your body, because they just want to look at your teeth. But we can use radiation for our own benefit.
Okay, yeah, and the technician always goes the dentist usually goes around back to like
that's right, because
take a photo.
You get one dental X-ray per year, but they have to do it like 10 times a day. So, it gets to be a lot.
For sure. So you mentioned the radio waves passing through everything. And then when we introduced you, we also mentioned that you're working at the Institute for Exoplanets. So are we using radio waves to look for aliens? I want to know.
We are, but there are different ways that you can look for aliens. And one of the ways is by using radio waves. So if you know the movie Contact or the book Contact, which Jodie Foster and Carl Sagan wrote the book, it's you would think that these astronomers are just like sitting around with all these radio dishes behind them, like listening on their headphones.
That's what I picture, for sure.
So it's not quite like that, but it's similar to that. Some people are listening to the universe in radio waves for intelligent life. Okay. So that's one way. Yeah, we're like trying to listen to their TV shows or their radio shows, essentially.
See if they're playing an FM station.
Exactly. But at the Institute for Research on Exoplanets, it's actually a little different. We're looking for life, but not intelligent life, more like microbial life or bacteria. Okay. So these are what we call biosignatures, and we can study exoplanets, planets that are outside of our solar system, and we can look very, very far away. And we can look at their atmospheres and determine what kinds of molecules are in there, like oxygen or
so you're
carbon
looking at
dioxide.
those planets' shields and they're
Exactly. Yeah, we're
protecting.
looking at their shields, and then we can find like signatures in their shields or their atmospheres that could indicate that maybe there is life there. Because like when you're breathing, you need oxygen to breathe in, you breathe out CO2. When you burp or fart, you are producing methane, and
you're giving off gas. Yeah, you're off-gassing.
Exactly, you're putting out gas. And those are biosignatures that go in the atmospheres of these planets, and they could be a sign of alien life. So that's what we're looking for.
Fun. Cool. So we talked a little bit about radiation sort of being a bit dangerous, and you mentioned people who work with X-rays wearing protection. So people who probably are wearing a ton of protection for space radiation, astronauts, how are they protecting themselves, and what are they doing?
So the astronauts, they are protecting themselves as best as they can, but there are lots of dangers in their job, and radiation is one of them. So I can go back to the little chart that I have. And this gives you sort of like, if you look on the right now, a level of radiation that you get performing different kinds of activities.
So tell me, hang on, before we get to astronauts, tell me about this eating a banana part.
Yes. Okay. I put it there because I know it's very intriguing. People see banana and they're like, what's going on?
It's breakfast time. I've just had a banana. Please tell me about the radiation therein.
Yeah. So in science, we measure things with units, and we measure the degree of radiation using a unit called a sievert. Or it's sort of like the meter, but for radiation.
Sure.
And then smaller subsets of that, we can go to a microsievert or a millisievert, etc. And so eating a banana is not dangerous, but you do get a little bit of radiation. Bananas are radioactive because they have certain elements inside of them, like potassium, that decay radioactively. And so when you eat a banana, you are in contact with 0.1 microsievert of radiation.
That sounds very small.
Very, very small. If you get one chest x-ray, you get 3 bananas.
Okay. It's not too bad, actually.
Yeah, 0.3. No, sorry. Not 3 bananas. Sorry. 300 bananas.
300 bananas.
300 bananas.
It would be impossible to eat that many. So.
Yeah, it would be a lot of bananas. But it's still quite low. And typically people, as we sort of walk around, we do encounter radiation now and again, but not that much, only about 2.5 millisieverts a year. And then
you get a bad sunburn, maybe a teeny bit more.
Maybe, or, if you're like hanging out in a construction field and someone is like using something radioactive, it's unlikely, but there you go. That is still totally safe. We do studies to figure out like what is safe. And that is 25 times below what is the like annual limit that is recommended.
Okay.
But
a big buffer.
Yes, there's like a really big buffer. But people who work really high up in the air, they have less of a shield above them to protect them.
They're higher up in the shield, in the bubble.
Exactly. So even pilots who aren't in space, but they're just higher up,
really?
They will, over the course of their career, go through about 150 millisieverts. So that's quite a lot more.
Well, closer to the limit. Yeah, for sure.
Yeah. But if you go up into space, now you're outside of the bubble, depending on how much time you're spending there and what you're doing, you can get up to 2,000 millisieverts over the course of your lifetime.
Wow.
So that's quite a bit. They do try to protect themselves. We mentioned some materials that can protect you from radiation. They try to build that into the space station and the space shuttle, everything. They like build it into the lining to try to protect them. But it is thought that people who are astronauts may have higher chances of developing cancer or harmful mutations in their genes because they are bombarded with so much space radiation compared to us.
For sure. Probably wouldn't come home with superpowers. They have other superpowers of just being in space and doing cool
exactly.
For sure. What speed does radiation travel at? We've talked about this coming out from the sun, from objects. Is it How speedy is it?
So radiation, when I mentioned it at the start, it like ranges all the different kinds of lights. So radiation is sort of just another word for light. And so all the different types that I talked about go at the speed of light.
Okay, nothing goes faster, and all the radiation is traveling at the same speed then? It's all at the speed of light?
Yeah, it's all at the speed of light if you're talking about the radiation itself. But if you're instead talking about like a particle or like dust or something that is radioactive and it's been blown out, like you're thinking of an explosion or like a nuclear reactor, that's not going to go at the speed of light. That's going to go at however fast that dust or that projectile is going.
For sure.
But the radiation itself, it's going at the speed of light.
Okay, that kind of reminds me of the Captain Marvel origin story where she absorbs the blast from, I think the fighter jet has crashed, so she kind of takes it up. But it sounds like we wouldn't achieve superhero status if that happened.
No, but the caveat to that would be that it was a Kree or an alien spaceship that exploded. So I've never gotten to study an exploding alien
spaceship. Tesseract, yeah, it's outside of our. For sure.
Maybe it would do something different and it would give you superpowers, but the types of radiation we typically deal with, unfortunately, would not.
For sure. Cool. And so the astronauts are protecting themselves. They are protecting the ISS and the shuttles and the physical spaces that they're in. If they're outside, they're wearing. We've all seen the huge suits with the giant helmets, giant gloves. But like outside of radiation, what happens to the body in space? Like there's no gravity. There's probably kind of a lot of things going on with your organs and your DNA and your brain. Who knows?
Yeah. And it's like a brand new field of study that's becoming more and more important because we're sending more and more people to space. So space medicine, there's like an institute in Texas now that like forms specifically space doctors.
Wow.
Yeah. And it's people who study the effects of space, the vacuum of space and microgravity on human bodies. And it's important for us to understand because we're planning on sending people to Mars or even farther. And we don't want to like put people in space for years and years at a time without knowing the effects.
How long?
Oh, go ahead.
Just curious, like for something like the ISS, what is the longest length of time that someone would spend up in space? I don't know.
So typically missions on the ISS take about 6 months.
Okay.
There have been some longer ones. It's typically between 6 and 12 months is like, they don't want to go really beyond that. But if you were to send someone to Mars, the one-way trip would take about 8 months. So
just getting there.
Just to get there. And then, you have to establish something there and then come back. So you have to like spend a long time in space. And all kinds of different things happen to your body. And some of the things that happen actually are similar to what happens to your body on Earth as you get older.
Oh, interesting. So it's just like a sped up aging process?
Exactly. Luckily, the astronauts, when they come back down, they can usually go through rehabilitation and exercises to try to get younger again and regain their strength.
Can I do this? Can I do exercises to
get younger? The exercise is always good. I think it always keeps us young no matter what. But yeah, they will do things like they will get muscle loss and their bone density will go down as they are longer and longer in space. And
so
that's just,
I have a question.
Yeah.
How do you exercise? Like, do they exercise in space? Like, there's no gravity, so they can't really do like bench lifts or something like that. Like, how does that work?
They not only do exercise in space, it is mandatory for them to exercise in space. Every single day, they have to spend a few hours in gym class.
Oh, wow, a few hours. That is significant.
And that's to try to counteract their muscle loss and their bone density loss that's due to the lack of gravity. But they have all these like weird devices, like they're strapped into the treadmill so they don't float away. And they have like, weight training and weightlifting, but it's all like these systems of pulleys to create a kind of resistance because they don't have gravity to resist against.
That's so fun. Wow, several hours. I maybe I don't want to go to space after all. For sure. So one question, how we've talked about like the ways that we can use radiation for good, X-rays, radio waves. One thing, can we use radiation? How do we use it for food safety, for killing bacteria or microorganisms? Like, how does that work?
So radiation, as I mentioned, can be really, really bad for us, but it's not only for humans. They can be bad for sort of all living creatures. And so one type of radiation that people use a lot is ultraviolet light to try to sterilize things.
For sure.
And you can use it for food. So you can try to sterilize the outside of your foods to try to kill viruses and microbes and that kind of thing. But you can also use them for medical tools or anything like that. Often at the doctor's office or the dentist office, they have these like little boxes and they put their tools in, they close the lid, and then a bunch of ultraviolet light blasts all of the tools to make sure that there's no germs left on them so that they can be used safely afterwards.
That's so fun. That's so interesting. Yeah, I had never really noticed that. I think they use UV treatment in the water systems as well, at least in Calgary. I think I've heard that. So yeah, that's fun. Awesome. So we've got a question about radiation, about everything emitting radiation. Do humans emit more radiation than our cell phones? How much is our cell phone emitting? Is this?
I know there's safe amounts.
What's that?
I know cell phones emit safe amounts of radiation.
Okay, like the microwaves.
Yeah, exactly. I don't actually know the strength of radiation. I know that we emit in different wavelengths. So humans, again, the type of radiation you emit is often linked to your temperature.
So the warmer things.
Exactly. So humans, we emit radiation in the infrared light, which is why if you've ever seen like a science fiction movie and they're like looking at things at night, they have like infrared goggles on.
Yeah, you can see like these green or red shapes sometimes.
Exactly. Yeah. So our temperature, like 37 degrees Celsius, is very bright in the infrared. But instead, cell phones, they're using radio waves to communicate with each other.
For sure. So that's different.
It's a different type of radiation. Yeah.
Cool. Awesome. Well, I feel like we just have time for maybe a few more questions. So I'll ask one. What is just like the weirdest thing you know about radiation? Like, what's your wackiest fact in your toolbox?
I've already talked about the banana, though.
Oh, the banana is is pretty good, actually. I'm going to remember that when I the next time I'm at the grocery store and I'm picking out fruit, I'm going to be like, that banana.
Yeah. So actually, I think it was XKCD who made like a comic, and the unit of measurement that they used was like the banana, I think. Nice. To like give you a comparison point how different activities scale on the radioactive level.
1 million bananas is
exactly
getting a sunburn. Cool. Awesome. Well, thank you so much for joining us. It's been really fun to talk about radiation and superheroes, and we're gonna kind of keep on the space theme next week. We're talking to Rachel Wang, who is an astronomer from Vancouver at the Macmillan Space Center. So we're going to keep on this astronauts as superhero theme, I think, a little bit. So yeah, you are working in space, and right now the Perseids Meteor shower is going on. So tell us something fun about that.
Yeah, it's a really, really great time of the year. What I love about the Perseids is that you don't need a telescope or binoculars or anything to watch them. It's accessible to everyone. You just need a dark sky.
You just look up and...
Exactly. You just look up, and you don't need to look at a specific part of the sky. You just lay back and try to watch the most sky possible, because you never know where the next shooting star is going to pop up. So you need
to kind of lay on a picnic table or something.
Yeah, you look at the whole thing. And tonight, the University of Montreal is organizing an online event. We always have an event for the Perseids in person typically, but this year it's online.
Which is great. So even if you're not in Montreal, you can.
That's right. Global. Exactly. It's in French, and it's going to be a few conferences that talks about astronomy, but like the human side of astronomy. And afterwards, online and on a radio station, myself and one of my colleagues, we guide you through an observation session of the Perseids. We sort of place you in the sky. We tell you where the different constellations are, and we tell you a little bit about what a shooting star is and why the Perseids are really, really cool. So
sweet. And then you can just lay back and make a bunch of wishes, because there will be shooting stars going everywhere.
That's right.
Hopefully.
Yeah, exactly.
No, that's awesome. And I think Spark has also released a digital stargazing guide. So some locations in Calgary where you might have some nice dark spots to stargaze from. I think there's a playlist as well, and some resources from the Royal Astronomical Society. So well, thank you so much for joining us, Nathalie. This has been really, really fun. And I'm excited for your Perseids event. I don't speak French, but maybe I will tune in and I can I can probably find a constellation.
Sounds great.
Awesome. Cool. Well, thank you so much.
Thank you.